Alright, doing a reassessment on rigid body equilibrium, and we have a problem of a beam A, B, and C is loaded via 500 Newton meters right here at point A, coupled in a 600 Newton force. The beam is connected to the rest of the system by a pin joint at B and a roller joint at point C. Determine the magnitude of the reaction forces on the beam at the support. First, I drew my free body diagram and showed the reaction forces, and at point B we have a pin support. It prevents components A, B from moving vertically and horizontally, and we have a vertical and horizontal component of force, and it's free to rotate, so there's no moment reaction. So we have reaction forces of RBX in the horizontal X direction and RBY in the Y direction. And at point C we have a roller support, and will constrain motion normal to the surface, and it's free to move tangent to this surface. So we have a reaction force in a vertical direction going this way, and we have the 600 Newton force going down in the 500 Newton meters couple force. So first we used a moment equation right here. The sum of moment B in counterclockwise would be a positive direction equals 0. So we have the negative 500 minus 600 times 0.3, which is the direction from the 600 force to point B, the plus RC times 0.4, which is direction from point B to C, the distance, equals 0. And so we solve for RC. We have 500 plus 600 times 0.3 divided by 0.4, and we have 1700 newtons for RC. And then we solved for, for the sum of the forces in the horizontal direction. For RBX, we have RC cosine 20 minus RBX equals 0. We solved for RBX, which is 1700 times cosine 20, and RBX force is 1597.5 newtons. And we solved for the sum of forces in the vertical direction, and we have negative RC sine 20 plus RBY minus 600. And we solved for the reaction force RBY equals 1700 times sine of 20 plus 600, and we have 1181.4 newtons. And to solve for the magnitude of RB, we have the Pythagorean theorem. RB equals the square root of RBX squared plus RBY squared. And we solve for that, and RB is 1986.9 newtons. So our magnitude of the reaction forces at the beam of the supports for RB and RC are right here.